Welcome back to my course on Fundamentals of Electrical Engineering. We were on control systems. We had covered time responses based on transfer function analysis, then again steady state error, and some of the responses as time goes on with respect to different kinds of inputs and in different situations. Now we are moving on to the modeling of the system. Here, the modeling of the system, as was mentioned earlier, in time response, you can use differential equations, you can use Laplace transform, but the basic nature, to derive the transfer function, you can have the block diagrams. You can also have a similar situation with a signal flow graphs. And for solving problems, especially in the gate context, you can borrow from each other. That is, when you're doing block diagrams, you can use the concepts in signal flow graph and vice versa. So just let us look at some of the problems. So the first one is very simple, but then be careful. It's a block diagram picture, the very general one. But what is asked is what is ES by RS and not CS by RS. That is the error. Okay, so this which of course you can derive as 1 minus G divided by 1 plus GH, or you can directly write it as equal to. Why is it 1 minus? Why? Because because CS is multiplied by H and it's going back, etc. So you can easily write it out as equal to 1 by 1 plus GH. Okay, so option C is correct. Okay, this is just the theoretical component. Moving on to the second problem. Signal flow graph is okay. Both block diagrams as also signal flow graphs offer their own ease of doing the problem, but at the same time, perhaps based on the way that you remember taking the takeaway points, etc. But we won't be discussing those. I'll be suggesting most of the easy methods, okay, and an overall view rather. So they are both used for finding the transfer function of a system. Okay, so option B is right in this case. So let's move to the third problem. The overall transfer function of the system is given. Yes. Okay, so here we are starting to analyze the block diagram from a different picture. Okay, so input is given and we trace the path towards output, and then we see if there are any feedback loops. Okay, so W is the input given. It is not split into two. It's given to both the block. Okay, please don't don't have any confusion regarding that. W is the input given to both comparators, both the comparator at the top as also the comparator at the bottom, and then they are processed, or they are getting a gain as given by G, and then they reach, and then they are added together. So now we are having two parallel paths for the input to flow, and in both paths you are getting a gain of G. Okay, and then they are added together, and then output is created. But at the same time, there is a feedback loop, as you can see, since they are identical. So you can as well take H, that is the feedback, from their own situations. That is, you can now it is cross-linked, but without even the cross-link, you can see them as being taken directly, because the signal that reaches after G is identical in both the parallel circuits. So now it's simply so it's simply 2 times, okay, 2 times G, which is because they are parallel, G divided by 1 minus. Why it is minus? Because the comparator is showing that feedback is positive in nature. So it is 1 minus GH, otherwise it would have been 1 plus GH. Okay, so 3 important things that we need to realize is that how the input progresses along the feed forward path. Second is, of course, where is the feedback coming from? Okay. Third is, of course, is the feedback positive or negative? Okay, very simple. Okay, let's move to an equivalent signal flow graph. Okay, so what do we have there? We see that there are 2 inputs. One is X1S and other is X2S. Okay, and then we are having Ys. X2S gets G2 and X1S gets 1, G1 and G2, or G1, G2 in the forward path. Ys is fed back via a negative feedback in the to G1, and it's taken back. Okay, And at the same time, from x to s, there is a feedback loop. Again, negative feedback is there because of -1, and then you are having g1. Okay? So now let's see what is asked out of us. Okay, for the signal flow graph shown in the figure, which one of the following expressions is equal to the transfer function ys by x to s is asked. Okay, of course, when you are having one input, the other input should be equal to 0, and that's what is marked here. x1 is equal to 0. So there's nothing there. You see that that x to s progresses towards ys through a single path which is equal to g2. So the numerator should have only g2. Okay, so from amongst the four options, we have B and C having a numerator equal to g2. Okay, now on the denominator, you are having 1 minus or plus depending upon feedback. Okay, so we have, let's look at the different loops that we have. We have one loop. Okay, now that's all that you have got. You're going to take the different loops and then add them together. So we have G2, G1 as a single loop. Okay, so going forward and then coming back. So we have G2 into -1 into G1. So plus G1, G2. Okay, so we'll have what is called as one component. It will be G1, G2. Okay, so now so in B and C we have G1, G2. So that's fine. Okay. Now let's see if we are having any other component. Yes, we have another loop. Okay, it's starting from x2 -1, 1 and g1. So we are having another quantity which is g1. Okay, and we see that only B has g2 on the numerator, 1 plus, because both the feedback loops happen to be negative, so 1 plus g1 plus g1, g2. Okay, so you go for B. Okay, so this is the way that you are going to pick up the feedback loops in signal flow graphs. Let's repeat the whole thing for the fifth problem. The signal flow graph of a system is shown. US is the input and CS is the output. Okay, and now we are given what may be called as, so let's start from the input. So we see that it's 0, 1 by S, 1 by S, 1, and we reach CS. You also have an alternate path, okay, because the direction sense is given by the arrow, so be very careful about that. We have another path starting from US. It goes via H1, then we have 1 by S, 1, and we reach CS. The other loops, the other paths are all feedback paths because they are directed backward. What else is given? It's also given that assuming H1 is equal to B1 and H0 is equal to B0, the input output transfer function GS is equal to CS by US of the system is given by. Okay, so first we look at the feed forward path. Okay, so there are two paths, as is obvious. H1 is replaced by now B1 and H0 is replaced by B0. Okay, this is just additional information. Okay, so now we have let's look at one of the paths. So we have H0, then 1 by S into 1 by S. Okay, so it is going to be B0 into 1 by S square. The other path is going to be H1, which is B1 into 1 by S. Okay, so in the numerator, okay, you are left with these two things only, and that's what we are doing. So for that express purpose, let's take s square to the denominator. Okay, since we are going to have 1 plus something, you can multiply throughout by s square on the denominator, which is easier. So what do we have there? Then we see that we are having h0 into 1 by s square now becomes only h0, or it's equal to, you will have b0 there. Okay, and h1, which is b1 multiplied by 1 by s, now has to have, because it's an addition, it has to have an s on the numerator also, such that you can have b1 by s square. So now, so numerator will have b1s plus b0, and we see that there is only one answer there. So now we just need to see if we can reconstruct the denominator. So s square has come down. Okay, so 1 plus y plus, because feedback loops have minus a1 and minus a0. There are only two feedback loops. Okay, so there will be only two contents in the two contents additionally to 1 in the denominator. So s square has come down, so 1 into s square, and then one of the loops happens to be 1 by s into minus a1. So that gets a s square from the numerator, which has come down. You get what is called as plus a1s. So there is one term a1s, and then you have minus a0 into 1 by s square. It becomes plus y because it is negative feedback, and then 1 by s square the s square gets cancelled because of the sweeping effect of the s square which has been taken to the denominator. Okay, so we have only a0 there, and so obviously option C is right. Okay, so first we take the numerator only, wherein we collect together all the feed forward parts. Okay, thereafter, if there is any squares of s etc., they are taken down to the denominator, and then you have 1 plus the different loops added together, 1 plus, so long as all the other quantities are going to be the loops are going to have negative values in them. Okay, otherwise they become negative as such. Okay, so now we have what is called as the square multiplying throughout, and so 1 is replaced by s square. Okay, and the other components also accordingly. Okay, I suppose the idea is taken, and we go to the sixth problem. Okay, so here again the same concept is investigated. What we have there, the system shown in the system whose signal flow graph is shown in a figure. U1s and U2s are inputs. The transfer function y(s) by U1s. Okay, so here we see that we have a forward path U1 to y. Okay, and there's also U2, but then of course we want y(s) by U1s, so it's definitely U2 is set as equal to 0. Okay, it doesn't play a part. Okay, and how many feedback loops do we have? We have only 2. Okay, one goes through minus k2, the other goes through minus r. Okay, so all these things are okay. So now let's start picking up the forward path. So what we have there? 1 by L into 1 by S plus into K1 into 1 by J into 1 by S square. So what we have? We have 1 by JL S square. Okay, multiplied by K1. So only K1 comes on the numerator. Repeating the same concept. Okay, so multiply every component in the feed forward path. So we have 1 by Lj into 1 by S square into K1. So only K1 comes, and Lj S square will be going to the denominator. Okay, so we see that from amongst A, B, C, D, we have JL S square as the first term, because 1 plus is going to come. Okay, so long as all the feedback loops are negative, we have ascertained that, because there is minus R and minus K2 in the feedback path. So 1 plus, so instead of 1, you will have JL S square. So that's settled. Now let's look at the next loop. That is, we are having minus R into 1 by L into 1 by S. Okay, so minus R into 1 by L into 1 by S. So minus R becomes plus R by LS is to be multiplied by JL S square. So we have 1 S there, we have J there. So the next quantity is going to be plus J, and then you will have R, and you will also have S. Okay, because 1 S is alone is was there in the denominator, and then you are having a sweeping multiplication by JL S square. So the second term happens to be JRS, and that's true only for option A. Okay, as was mentioned earlier, when there's some kind of complication, you will see that option A or B happens to be right. Okay, now let's move to the next one, just for confirmation. Okay, we have already arrived at the answer. The next loop is going to be minus K2, so that gives you plus, and then you are having J, you are having L, 1 by L, 1 by S, K1, 1 by J, and 1 by S in that particular row. Okay, so K2 will be there, okay, and you will have JL S square have been already cancelled with respect to the sweeping effect of JL S square, and so you are going to have only K1 and K2 there, and the product becomes positive. Why? Because we are having negative feedback. So now we have K1 on the numerator, very simple concoction, divided by JL S square instead of 1, and then J, and then for the first loop where we are having R, that is reinstated, and 1 by L and 1 by S are removed, but the remainder, that is J and S, will come into the picture. So we are having JRS. Okay, and then all terms are positive. Then we have the last one where the 1 by JL S square is already cancelled by JL S square from the numerator, and then we are having only K1 and K2 there. Okay, very simple. Okay, I hope that you realize that it's very simple. Okay, if you go about it in this manner without doing any other kind of computations, okay, without taking out any takeaway points and things like that. Okay, so let's go to the last of the lot, the seventh problem. Find the transfer function y(s) by x's of the given of the system given below. So let's follow the input. X is now reaching, okay, not splitting, but it's reaching two comparators, and there you're having negative feedback, so it's going to be plus. And then what we have here, we have two paths of progression for the signal. One is G1, the other is G2. They reach YS, okay, and then they are added together, but then from YS they are fed back, okay, fed back via H to both the signals. Okay, so what we have there, we see that on the numerator we are having, okay, so I suppose this is clear. You can see a signal flow graph there, and what happens to the signal goes via G1 and G2. So it's an AND circuit, so G1 plus G2 should be on the numerator. Okay, on the denominator you see that there is going to be 1 plus, okay, because there is, so 1 plus because the feedback is negative. And what we have there, we have the fact that there is one loop as given by G1H, the other loop as given by G2H. Okay, so now we are having G1 plus G2 divided by HG1 plus HG2. Okay, just the idea has now been borrowed from the signal flow graph, which we have already understood based on the loops, the feedback loops. Okay, so as simple as option C is going to be the answer to this particular problem as well. Moving on to the block diagram of a system is given in the figure. Yeah, there is RS. It is fed by an integrator 1 by S, and then it's added together. There's a comparator, and then we are having GS, and then S again, and then finally we are having CS. That's the feed forward path, and there are three feedback loops. Okay, so we have so one from a takeaway point after GS, and other. Yes, there are two feedback loops that are emerging from the takeaway point after GS. One is fed back directly, and other is fed back a little further away. Okay, so we also have a feedback from after S going back to GS. Okay, so this is the system. So there are three feedback loops. Okay, so there should have been. There's a mistake in the problem, but still let's continue. The mistake, I noticed a mistake in the problem, in the answer, etc. But then let's correct it and go ahead. Okay, the desired transfer function of the system is CS by RS. Okay, CS by RS is equal to S. So numerator should have S. Okay, and denominator should have S square plus S plus 1. Okay, so now numerator can have S only if GS is equal to, for the time being, S. Why? Because if you look at the feed forward path, which is what we always did, 1 by S into S becomes 1, and then you have GS, so you need to have an S. Okay, so one of the answers, you have 1 by S, you have S as answer B, you also have minus S. Okay, so that is also not true. So S, let's check with S. Okay, so you have S there. Now let's pick up the different if GS is equal to S, what is going to happen? So how many loops are there? Okay, so we have we start from you should have 1 first, because 1 plus, okay, because all the feedback loops are negative. So 1 plus, then you have GS into S in one loop, so that should be equal to S into S square. So we have 1 and S square is already there. The second loop will be, then another feedback loop will be S into 1. Okay, so I suppose the first one, that is the GS and the simple feedback loop. Okay, so that's equal to again S. So S square plus S plus 1 is okay. But now we are having another one, that is 1 by S into S. Okay, and fed back to just after RS. So what do we have there? 1 by S into 1. So you should have another 1 as well. So it should be S square plus S plus 2, though the answer is given in a different manner. Okay, all the other answers don't fit, so you go for option B. Okay, the signal flow graph for a system is, I suppose by now, how to use the block diagram using the concepts from signal flow graph and signal flow graph. Okay, so that's perhaps a little tougher. It's easier to use the signal flow graph concept, but then you should not lose track of what is the feedback negative or positive. Okay, so let's look at this particular problem. It seems to be a little more complex because we are having we are having only 2 feedback loops, but and two feed forward paths. Okay, so when you are having two feedback loops, you will have three terms on the denominator. Okay, so that is plus one. Okay, on the numerator, as many feed forward paths are there, so many terms will be there. Okay, so now what we have, signal flow graph for a system is given below. The transfer function ys by us for the system is. Okay, so as usual, job number one is to collect the feed forward paths. What are they? We have s raised to minus 1 into s raised to minus 1 into 1 and 1. Okay, so we have 1 by s square. Okay, so 1 by s square is one of them, and you also have an additional path where 1 s raised to minus 1, 1 and 1 alone are included. Okay, so we are having 1 by s square plus 1 by s. So automatically the numerator is going to be, okay, s square plus s plus 1, because 1 by s square plus 1 by s tells us that you will have s plus 1 and s square will be taken to the denominator. So far so good. So from amongst a b c d, we avoid or we neglect option D because it doesn't have s plus 1 on the numerator. Okay, so now remember the s square there, and now let's start taking each of these feedback loops. Okay, so we see that we are having the first loop with 1, okay, for 1 on feed forward path and minus 4 on the denominator. So feedback is okay, negative feedback is okay, and that gives us 4. Okay, so now we are having s square which has gone to the denominator, multiplying the 1 there, and also now we are having this 4 there. Okay, so plus 4. Okay, so 4 plus 1, 5 into s square. 1 because of because of 1 plus all the loops, so 1 is already there, and minus 4 into 1 has become plus 4 because of negative feedback. So we are having 4 plus 1 into that's 5s square. So from amongst the answers we are having, we see that A and D we have already neglected, so A is right. We are having 5s square, s plus 1 by 5s square. So far so good. Now we'll just simply check out the other loops. Okay, so let's go for the loop which has s raised to minus 1 and minus 4. Okay, so that's again 4 by s multiplied by s. S is giving us 4s. Okay, so only 6s has only now 4s left. Okay, so now let's go for the next loop. That is, we see that s raised to minus 1 into s raised to minus 1. Okay, multiplied by minus 2. Okay, so that's equal to 2 by s square. So multiplied by 2 by s square multiplied by s square gives you 2. So the last term is also okay. So now we hunt around to see if we are going to have any other feedback loop. Yes, we have one. What is that? We have s raised to minus 1 into 1 divided by 2. Okay, so the loop is completed through, that is, the outer loop is completed through s raised to minus 1, 1 in the feed forward path, and then minus 2. Okay, so what do we have there? We have 2 by s. Okay, so if it is 2 by s, multiplying by the s square gives you 2s. Okay, so we have, the earlier we had already 4s plus 2s is equal to 6s. Nothing is written because you can simply just go put your mind's finger on each of these parts and you can go ahead. Okay, so what do? We find the numerator first. Remember, there is 1 on the denominator, plus or minus depending upon the feedback, and then collect each of them and see if some of the pieces fit together. If that is so, then just see to it that the rest is okay. Okay, so let's go to the 10th problem. What do we have there? Okay, so we have a complex kind of situation. Yeah, we have yeah, so, and what is asked is, okay, so we'll check it out. Okay, so there is an input coming and it's going to C0 and C1. Okay, afterwards they are both going to some comparators, adders. Okay, and then they are emerging, and whatever goes to C0 gets 1 by s as also 1 by s and p to get to the output. Okay, on the other hand, what gets to the input coming to C1 or magnified by C1 gets only 1 by s. Okay, and there are two feedback paths. Okay, one is after p. Okay, it's going back to b1 and b0, and then they go to and thereafter whatever goes through b1 obtains only 1 by s, whereas b0 whatever goes through B0 is having both the integrators. Okay, and after yeah, in the feedback loop we also have before P we are having A1 and A0. Okay, returning to one integrator case or two integrator case in a cascade. Okay, so yeah, the system shown in figure below can be reduced to the form. Okay, so let's compare the form there, because all the quantities, that is x, y, and x, y, and z are explained, and we are supposed to pick up the correct one. Okay, so where do we proceed from? Okay, so we see that we are having the P is restored, X, Y, Z happen to be new. Okay, so P is restored, and there's only one feedback path which is going from the output of both the systems. Okay, so we compare this. So we start with Z. Okay, I hope this is clear. We start with Z because it's going back. Okay, and what are we seeing there? We are seeing that we are seeing that yeah. So whatever is going back? Okay, we see that it is passing through B1 and only one integrator. Okay, whereas the other is going through B0. Okay, and then it's in the feedback path, there's no doubt about it, but it has two integrators. So now we compare. Yeah, B1 has only one integrator, so it has to be multiplied by S if S has to go down to the denominator. Okay, and B0 will not get, since it is B0 into 1 by S square. This is the feedback path. Okay, so we'll retain it as it is. Okay, so from amongst the four options for Z, yeah, we have only option D as correct. According to this estimate, Z is not equal to 1. It has both B0 and B1, and only B1 is multiplied by S, because S square would normally be taken below. Okay, so after Z we examine X. Why? Because the input L also has a sort of a distribution wherein we are having C1 and C0. Okay, so we are having C1 and C0, and as was mentioned earlier, C1 is going to be C1 is going to be having only one integrator, that is whatever passes through C1, and whatever passes through C0 is going to have two integrators. Okay, and so we see that they are going to be on the feed forward path. Okay, because X is in the feed forward path, Z is in the feedback path. Okay, so it should have what is called as, so they should all be multiplied together, and S square is going to be taken down to the denominator. So what we have there, you are having C0 plus C1S. Why? Because S square is taken to the denominator. So again, in case D, that matches. Okay, so now we're just seeing if that D is correct, because we already saw that Z is accordingly right according to whatever we have been talking so far. So B1S plus B0, and C is equal to X is equal to C1S plus C0. Now Y alone. Okay, so S square has already been taken to the denominator, so we are going to have 1 by, because feed forward path is already collected except for Y, so Y is going to, and P is already there, so Y is going to be 1 divided by, and the S square that has been taken to the denominator is now appearing as 1 into S square, so that's okay. And then we have two feedback loops again that need to be managed. One is with 1 by S and A1. So it has to have what is called as, yes, it has to have 1 by S into A1 multiplied by S square, so it's going to be A1S, so that's also true. And then you are going to have 1 by S into 1 by S into A0 as the next loop, so you are going to have 1 by S square A0 into S square, so you see that. Okay, all the components X, Y, Z are appropriately fitted in the simpler version of the complex kind of block diagram, which has only X, Y, Z, and P. Okay, only P has been retained, so that's the reason why you start from the output of P. Okay, because the outputs should match, and they happen to be the feedback loop, and that's where we started off. Okay? The input can also be taken as the first situation, so long as you understand that X is now going to replace the a common comparator. Okay, so it's in that context I suggest that you start off with Z, you go on to X, see if they fit in any of the options. Okay, and later on see that whatever we have been whatever we have been assuming are true associated with Y as well. Okay. So let's go to the. So I have picked up a lot of questions here because they happen to be very simple, and once you follow everything, it will be easy. Okay, so it will be a longer session. Okay, so now we are having a block diagram with 1 by S and 1 by S. Okay, so yeah, and then yeah, so we see that we are having okay, unfortunately the arrows show that we don't have feedback loops. Okay, we are having RS going through two integrators and reaching CS. RS is also going through one integrator only to reach CS, and RS is going directly. Okay, so how do you write it out now? CS is the combination of RS coming directly. So the RS into 1, then RS into 1 by S, then it's also having RS into 1 by S square. Okay, so this is the most important observation that you need to make, the direction of the arrows. The direction of the arrows tells us that there aren't any feedback loops at all of the signals go forward once one of the signal that is RS goes directly to CS, and other goes via a single integrator. One goes through two integrators. Okay, so and all these signals are summed up to get you CS. Okay, so now we are having yeah. So the denominator will have S square, and the numerator will have 1 plus S square. Okay, so option B is right. Okay, so let's move to the 12th problem. The block diagram of a control system is shown. Your UT, YT, and then you are having yes, you are having three feedback loops. Okay, one is with 3, another is with 12, the third is with 9, and there are two integrators as also 2 on the numerator. Okay, so we have 2 into 1 by 1 by. Okay, so now let's look at the context of each of these integrator come feedback things. It's going to be the same as equal to 1 by S plus 3. Okay, the first one. The next one is going to be 1 by S plus 12. Okay, so 2 into 1 by S plus 3 into 1 by S plus 12. Okay, because of the feedback. Okay, so we see that that's going to be the feed forward path. Okay, so now we can just yeah, so now we can just simply take the overall transfer function. So we have 2 on the numerator, and then we are having S plus 3 into S plus 2 plus 9 and 9, because it's so now the whole assembly is going to be, so here we are using the block diagram understanding. Okay, so now this, the two individual feedback loops, that is with 3 and 12, are now going to be getting a common feedback by 9. Okay, so that's the reason why 2 is coming on the numerator, and then S plus 3 and S plus 12 are coming together. 1 multiplied by S plus 3 into S plus 2 plus 2 into 9, because 9 happens to be on the feedback. Okay, just as we discussed in the earlier case. Okay, so now you can settle them all together. So you see that you are having 2 divided by S square plus 15S plus 54. Okay, so that 54 tells you that you can have 9 6 the 54, and 15 tells you that 9 and 6 can be equal to 15. So they have been resolved into 2 by S plus 6 into S plus 9. So you can take out yeah, you can take out 9 and 6, because that's how the pattern is given. So we see that 2 by 54 is 1 by 27. So and so B, C, D are okay, and then you are having 1 plus S by 1 plus S by 6 and 1 plus S by 9 only in answer B, and so you go there. Okay, so what have we done here? We have gone through 2 steps. Okay, so of course this therein you might use pen and paper, etc. First we observe 2 individual feedback loops, 2 individual loops, 1 by S plus 3 and 1 by S plus 1 by S plus 12. Okay, multiplied by the other component of the feed forward path, which is equal to 2. Okay, so 2 into 1 by S plus 3 into 1 by S plus 12 is now getting getting a feedback of 9. Okay, and it's also a negative feedback. So again we are having 2 on the numerator. Okay, and on the denominator you are having, instead of 1, S plus 3 into S plus 12, and then plus 2, okay, which was in the numerator, multiplied by the feedback, which is 9. Okay, so then resolve them, and then see if any of the options match. Okay, so let's look at the last problem. There is the 13th one. There are it looks a little complex. So, and the question is, the signal flow graph or figure shown below has how many forward paths and how many feedback loops. Okay, there are few errors, like for instance there's a connection between the point where A is the magnification straight ahead, but there's no alphabet given there, so it means that there's nothing there. Okay, so please imagine that. And the K has been had no arrow, so I have put an arrow there, okay, to show that it's feed forward. Okay, so now let's start collecting the feed forward paths. A, B, E, F, G is obvious. Again, it has been marked out. Okay, that's that. But you are supposed to pick up in the examination context. A, B, D, F, G immediately comes through. Okay, let's go via K. So there are only two paths leading after A. So that's the next one. A, K, L, F, G, A, K, MG. Okay, so four. Okay, in all other cases you encounter a roadblock. So that's all that's there. So four feed forward paths. Feedback. Yeah. So we have at the bottom picture. Don't go for K or B because they are all leading outward. Okay, so we have LFN and LFM. That is two. No, sorry, LFN and MN. So there are two feedback loops. Another is DE. Then you'll see that you don't see anything except for C right at the top. Okay, so that's something that we saw when we were removing one of the two inputs. We saw that there were feedback loops on the other side as well, at the input side as well. Okay, so we have C also. Okay, so it's 4 feed forward and 4 feedback. So the last problem, the last slide, there's a block diagram. Yeah, so from RS we move via G1 and G2 and G3 and reach CS. We see a feedback path right at the output, G2, G3 and H2 negative feedback. Then again the next one is G1, G2, H1 with a negative feedback. Okay, so we have G1, G2, G3 on the numerator as always, and they are present in all the options. And then we are having one loop, 1 plus. Okay, never forget that 1 plus, y because both the loops happen to be negative. Okay, then we have having G1, G2, G3, H2, G2, G3, H2, G2, G3, H2 is there in A, in B. No, we don't have it in B. We don't have it in C or D. So now we just need to confirm whether the last one is right. Okay, the last term is G1, G2, H1. Okay. Yeah. So far we were discussing. So that's all. So far we were discussing how how you can borrow concepts from block diagram to signal flow graphs and signal flow graphs, mostly signal flow graphs to block diagrams. Okay, so 4 points or 5 points that we can remember happens to be that you can start from the input and go towards output, but never decide or be confused that the input is getting split. Then input goes in its full entirety through one or more paths towards the outputs. Okay, so your duty is to pick up all the paths and put them on the numerator. Okay, on the denominator we are having 1 plus. Okay, plus if all the loops happen to be loops both in the transfer function in the block diagram or in the signal flow graph. Okay, so 1 plus if they are negative feedback. Okay, so now collect together each of these loops and put them together. Okay, most often than not, some of the components in the numerator will be fractions, so we will have denominators, so they will be coming to the denominator of the overall transfer function and multiplying each of these components. So don't be at all confused. Just pick them up one by one and okay, you can go ahead. Okay, so first look at the numerator from amongst the answers and pick out the correct ones. Okay? And then thereafter pick up one or two of the terms which are easier to be done, and thereafter see if they all fit together. Okay, so that's all that needs to be done. It is again another easiest portion in control systems, and you can score all marks so long as some of these questions come in the GATE examination. Okay, thank you.